Hello, good afternoon, everyone. So, welcome to the extra tutorial session. This session will be based on all the lectures which are uploaded on NPTEL portal of the course Introduction to Robotics. So, basically, in this extra session, we will discuss tutorial sessions like questions based on all the week lecture session. So we'll start from the week one and we'll solve at least one or two problems or at least two or three problems from every week so that we will get to know what is taught in the complete course, and also this can be useful if somebody is preparing for the exam for this course. So first we'll solve few questions from the week one, that is based on the transformation transformation of one coordinate axis to the another coordinate axis. So the first question is, like, if a physical point in three-dimensional space is expressed in terms of its homogeneous coordinates, we want to change from one coordinate frame to another. We use a 4 cross 4 uh, homogeneous transformation matrix, where R is the homogeneous rotation matrix. So in this question, it is asking where R in the homogeneous transformation matrix T represents. It is asking about the R. So first we will see what is there in the transformation matrix. Whenever we write a transformation matrix, it consists of R. So that is R11. That is a rotational matrix. And it is a 4 cross 4 homogeneous. So rotational matrix will be 3 cross 3. This is 0, 0, 0. And this is the position vector, that is Tx, Ty, Tz, and this is 1. So here, this is our R, and R is rotation matrix, that is of 3 cross 3. Okay, so it is very simple question. Also, we will see how this R is calculated. Okay, so there is no question based on that. But anyway, I will go through the basics. Let's suppose there is a coordinate axis which have uh, F1 as one axis, F2 and F3. Okay, and this is another coordinate axis M1, M2 and M3. So the transformation matrix T is given as F1 dot M1, F1 dot M2, F1 dot M3, F2 dot M1, F2 dot M2, F2 dot M3, F3 dot M1, F3 dot M2 and F3 dot M3. Okay. So we will see. We'll solve the another question. And this video will be uploaded on YouTube. So and the link will be also shared. So if anyone missed this lecture, then you can watch on the YouTube. So now coming to the next question, that is a frame B is rotated by 60 degree about Z axis of A, like frame A is there, and B is rotated by 60 degree about the Z axis of A. If the coordinate of point P in frame B has the coordinate 1, 1, 1, what is its coordinate in frame A. So let's suppose this is our frame A. Okay. Now the another frame is B, like this. And if this is the Z axis of frame A, so it is rotated 60 degree along with the Z axis. So after rotation 60 degree about Z, frame A is the first frame, so it will be same. Now frame B, the Z axis will be same, only the X and Y axis is rotated by theta, that is equal to 60 degree. Okay. This is frame B and this is frame A. So now it is given that PB means point in frame B is given as 1 comma 1 comma 1. So we have to find PA, point of B with respect to the frame A, that is A into PB. Here A is the transformation matrix, or we can also write here T. There is no translation, so we'll only take the rotational parameter. So RZ, we all have studied that when rotation along Z axis, that is RZ alpha, is given as cos alpha minus sin alpha. Like you can directly do this dot product and you can find, you will get this value. Sin alpha, cos alpha, 0, 0, 1, and this two term will be 0, 0. So now here alpha is, let it take, so this is alpha. So alpha is 60 degree. So when we substitute the value of alpha, we will get the rotation matrix RZ alpha, that cos 60, that is 1 by 2, minus sin alpha, that is minus root 3 by 2. Then again this is sin alpha, that is root 3 by 2, and cos alpha will be 1 by 2. And this term will be remain same. So this is our T here. So now we have to find PA. So that PA will be 1 by 2 minus root 3 by 2, 0, root 3 by 2, 1 by 2, 0, 0, 0, 1. And what is the coordinate in with respect to frame B? That is 1, comma 1, comma 1. So PA is equal to 1 by 2 minus root 3 by 2, root 3 by 2 plus 1 by 2 and 1. So this is equal to 0.5 minus, that will be minus 0.366, 1.366 and 1. So in this way we can find a point in one coordinate frame and what will be the value in the another coordinate frame. So again here question is same, but there is one twist in this question. In this question, a frame B is rotated about 60 degree about the z-axis of A and then translated by 2 to 2 units in xyz direction of A. If coordinate of point P in frame B is 1, 1, 1 and its coordinate in frame A. So now here is translation and rotation both. Rotation is alpha is equal to 60 degrees, same as the previous question, and translation is 2 comma 2 comma 2. So our transformation matrix will be, rotation matrix will be same, 1 by 2 minus root 3 by 2, root 3 by 2, 1 by 2, 0, 0, 0. So this is 4 cross 4, and translation is 2 to 2 units in each direction. So here what happened? First, first the axis is rotated by 60 degree, and then it is translated in each direction by 2 to 2 units. So the same thing will be somewhere, this is 2, this is 2, and this is 2. So somewhere here. Okay, like this. So just imagine in your mind, you will get it how it happened. Sorry, here this term is 1 because this is our rotation matrix. Now we'll keep our point, and then this is okay. So first you remove this. Now PA, that is point in the coordinate axis 1, will be P into PB. So that will be equal to 1 by 2 minus root 3 by 2, 0, 2, root 3 by 2, 1 by 2, 0, 2, 0, 0, 1, 2, and 0, 0, 0, 1. And PB is 1, 1, 1, and this last term we will add 1. So finally our PA will be minus 0.366 plus 2, 0. Sorry, 1.366 plus 2, 1 plus 2, and 1. So when you do this, you will get 1.63, 3.366, 3, and 1. So point in A will be 1.63, the x-axis, 3.366, the y-axis, and 3, the z-axis. So like this, we can solve this kind of question. So we have plenty of question today. So little fastly we'll solve so that we can complete all of this question 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 more questions we have. We'll try to solve within 1 hour. So now these questions are based on the lecture of week 2. So here it is asking what are the values of A1, D1, A2, D2, and alpha 1, alpha 2. So these are the DH parameter as we know. So this is our first axis. So we'll assign this is L0. This will be our B1. Again, this will be B2, L1. This is L2. Okay. Actually, BK is intersection of XK and ZK minus 1. So here you see B1 will be the intersection of x1 and z naught. So x1 and z naught will intersect here. So that is B1, and B2 will be the intersection of x2 and z1. So that there is the B2. So like this, okay? Now we have to find A1. So what is A1 here? As we have studied in DH parameter, that AK is the distance from points BK to the origin of the frame LK measured along XK. So AK is the distance from the points BK to the origin of the frame LK measured along XK. So now we have to find A1. So A1 is equal to like B1 to the origin of frame L1. So B1 to L1 origin along XK. Simply we can write this like this. So B11 is this, L1 is this, and along XK. So this is our A1. So A1 is equal to 100 minus 0. So this term will become 100. Okay. A2 is again B2 to L2. Origin means origin of L2 along X2. So B2 and L2. So this gap is the A2. So that is equal to 40 centimeter. So AN we can write as 100 centimeter. A2 is equal to 40 centimeter. Now we will solve for D. So DK is equal to origin of LK minus 1 to BK along ZK minus 1. So D1 is equal to origin of L0 to B1 along Z0. So L0 to B1 along Z0, that is 0. So D1 is equal to 0 centimeter. D2 is equal to origin of L1 to B2 along Z1. So L1 and B2 again coinciding. So D2 is also is equal to 0 centimeter. So finally we have solved all the four parts. Now the last two part is the alpha. Alpha k is the rotation of Zk minus 1 to Zk measured along Xk. So alpha 1 is equal to Z0 to Z1 along X1. So Z0 and Z1 have the same direction along X1. So this is equal to 0 degree. And alpha 2 is equal to Z1 to Z2 along X2. We'll see the direction of X1 and Z1 and Z2, that is again parallel. So this is also is equal to 0 degree. So the answer is 0 and 0. So we have solved all these parts. If you have any doubt, then you can ask in the comment section of YouTube. Okay, so we'll move on to the next question. Now this question is based on the week 3. So here this is the transformation matrix. So this part of the transformation matrix is the R, that is 3 cross 3, and this is translation, that is 3 cross 1. So the first part is rotation, R 3 cross 3, and this part is translation, 3 cross 1. So T of BW is equal to, like, rest with respect to base transformation, is R T 0 0 0 and 1, like this. Okay. So this is the position Px, position in y direction Py, position in z direction Pz. So find the position coordinates of the wrist with respect to the base of the robotic arm. So we have to find Px, Py, Pz. So Px is equal to, it is given C1 A2 C2 plus A3 C2 3. So this is equal to cos of theta 1 into A2 cos of theta 2 plus A3 cos of theta 2 plus theta 3. So here theta 1 is 90 degrees. So cos 90 degrees is 0. So this term is 0. This means the whole term is 0. Okay. Now Py is equal to S1 A2 C2 plus A3 C2 3. So this is equal to sine of theta 1 A2 cos of theta 2 plus A3 cos of theta 2 plus theta 3. So sine 90 is 1 into cos 90 is 0 plus A3 and cos theta 2 plus theta 3, that is equal to cos 135 degree. So this is equal to 1 into A3 into cos 35 is minus 1 by root 2. And A3 is given as 177.8. So the answer will be 177.8 divided by root 2, that is in the negative. So Py is equal to, when you calculate this, you will get minus 125.7. So option C and option D may be correct. Now check for the next one, that is P of Z, that is equal to D1 minus, we'll take into the next page. So P of Z is given as D1 minus A2S, sorry, A2S minus 2 minus A3S2 3. So this can be written as D1 is 250, 250 minus A2, the value of A2 is 177.8 into S minus 2, that is equal to sine of 90 degree, and that too in the minus. And then minus A3, so minus 177.8 sine of S23 145, 135 degree. So when you calculate this, you will get 250 minus 177.8 into 1 minus 177.8 into 1 by root 2. So the final answer will be minus 53.5. So the correct option is option C in this question. That is 0, minus 125.7 and minus 53.5. So now this question we have. So here, this is our L naught, L1, L2, L3, L4, and L5. So first we'll assign the coordinate axis. This is X naught, Z naught, Y naught. Here again, this will be X1, Z1, and this will be Y1. This will be Y2, X2. You can go through the lecture how we are assigning the coordinate axis. This will be X2, and I have already discussed in this. So it will take half an hour if I again discuss. So I'm directly solving the question. So this will be our X3, Y4, X4, and Z4. And finally, this is our Z5. So this is L1. Now we will assign B1, B2. We have already discussed B1, how to do B1, B2, and B3 all calculation in the previous question. This is B4 like this. Okay. So dk, we have to find dk and a. So dk is lk minus 1 to bk along zk minus 1. So d1 is equal to L naught to b1 along z naught. So let's write d completely. So L naught to b1, b1 is at 300, so it will be 300. Next is L1 to b2. So L1 and b2 is coinciding, so it is 0. Another one is L2 to b3, again 0. Next one is L3 to b4, again 0. And another one is L4 to b5. So this is 151.5. So this is our D. Now AK is distance between BK to LK measured along XK. So our A1 is equal to B1 to L1. B1 and L1 is coinciding, so it will be 0. B2 to L2, this is 210. Then B3 to L3, again this is 210. B4 to L4, that is again 75. And B5 to L5. So B5 and L5 is coinciding, so this will be again 0. So the correct option is 300, 151.5 transpose. And the second is 0, 210, 210, 75, 0. So the option D is the correct answer for this question. So now we will solve the question on pseudo inverse. That was taught in the week 4th. Pseudo inverse is also known as Moore-Penrose inverse or pseudo inverse. Both are same. So pseudo inverse of B is written as B plus, that is Murray-Penrose inverse or pseudo inverse. So B dagger, that is equal to BT, B of B transpose inverse, and here M is less than or equal to N. that is number of row is less than number of column. That is equal to B inverse when M is equal to N. So this is when the square matrix is there. Basically, pseudo inverse is calculated for non-square matrix when rows and columns are not equal. And this will be B inverse into B transpose when M is greater than N. This means number of row is greater than number of column. So in this question, we can see that M is less than equal to N. Number of rows is 2 and number of column is 3. So we will use the first formula. So the pseudo inverse will be B transpose B of B transpose inverse. So B of B transpose can be written as 106 2 minus 10, and transpose of this is 120 minus 160. So when we multiply this, we will get 37 2 2 5. So this is 2 cross 3 and that is 3 cross 2. So the final answer will be 2 cross 2. Now we have to find the inverse of this. So this can be easily done. That is the determinant of this is 37 into 5. That is 185 minus 4. 1 by 181. And here just change the and give here minus sign. So this is the inverse of 2 cross 2 matrix we can find. So now we have to find that is B dagger, that is the pseudo inverse is equal to BT into B of B transpose inverse. So this is equal to, so this is B transpose and B of B transpose inverse is 5 minus 2 minus 2, 37. So this will be 1 by 181, 1, and another will be minus 2 plus 74, that is 72. This will be 0 plus 2, 2, 0 minus 37, 30 minus 12. So this is the pseudo inverse of matrix B. So this question is done. So now we will move on to the question from the week 5th. Like we will be solving one or two questions from every week. So in this question, it is given a rectangular coil having length 10 centimeter and width of 5 centimeter. So just write down what are given in this question. Like 0.1 meter, width is equal to 5 centimeter, that is equal to 0.05 meter. Placed in a uniform magnetic field of flux density 1 Tesla. So the B, that is equal to magnetic field density, that is equal to, so that the plane of the coil is at an angle of 30 degree to the direction of field. If the coil has 10 turns, N is equal to number of turns, that is equal to 10 turns, carries a current of 5 ampere And it is asking the torque experienced by the coil, and we have to write up to 3 decimal place answer in Newton meter. So the formula of torque as taught in the lecture is NBI cross DL. So that will be IL sine theta and into W, that is the width. So here all these parameters are given, that is 10 into 1, I is given 5, L is given 0.1, theta is angle of 30 degree to the direction of field. So theta is 30 degree. So sine 30 degree into width is 0.05. So this will be 5 by 2 into 0.05. So answer will be 0.125 Newton meter. Now moving on to the next question, that is a rectangular coil having length 10 centimeter and a width of 5 centimeter and 10 turns. Let me drink some water. So around 6 questions are left. It will take around half an hour or 40 minutes more. A rectangular coil having length 10 centimeter and a width of 5 centimeter and 10 turn is placed in a uniform magnetic field flux density 1 Tesla such that the coil inside the perpendicular to the direction of field. Now here the coil sides are perpendicular to the direction of field, so theta will be 90 degree. If the coil is manually rotated at a speed of 1000 rotation per minute such that the axis of rotation is perpendicular to the direction of the field, the peak value of EMF developed across the coil we have to find. So we have to find the peak value of EMF. So the value of EMF can be calculated using this formula 2 into N into B into R, L into R into W. Here W is the omega. So omega is equal to angular velocity, that is given as 1000 rotation per minute. So that is equal to 1000 into 2 pi by 60 radian per second. Okay. Why like this? Because one rotation contribute 2 pi radian rotation and 1 minute is equal to 60 second. Number of turn n is given 10. B, that is equal to flux density, is given as 1 Tesla. L is equal to length, that is given as 0.1 meter, and R is equal to radius, that is equal to W by 2, width by 2. So that will be 0.05 by 2 meter. So now substitute all the value. EMF is equal to 2 into 10 into B is 1, L is 0.1, R is 0.05 by 2, and omega is 1000 into 2 pi by 60. So the final answer will be 10 pi by 6, that is equal to 5 pi by 3. So it will be 15.7 by 3. So that is equal to 5.233. So the peak value of EMF is 5.233 voltage. So now we will solve the next question. So in this question it is given the rotor of a brushless DC motor rotates at a speed of 1200 rotation per minute. So omega is equal to 1200 rotation per minute. And the rotor of the brushless DC motor has four poles. So pole is equal to four, two north pole and two south poles. The frequency of the output pulse for each Hall effect switch is in hertz. So the speed of rotation is equal to 120 into frequency by poles. So we have to find frequency, that is equal to P into omega divided by 120, that is equal to 4 into 1200 by 120. So this is equal to 40. So question 7 was 40 hertz. So now we will solve question based on the week 8. That is, a robotic application demands precise sensing of the angular position of motor shaft to an accuracy of 0.25 degree. It is decided to use an absolute encoder for this purpose. What should be the minimum number of bits that need to be there in the encoder specification for achieving an accurate measurement of the angle? So first, let's suppose this is a trial question, trial based question. So you have to take, let's suppose n is equal to 10 bits. So resolution is equal to, so in complete rotation will be 360 degree. 360 degree divided by 2 to the power of 10. So that is equal to 360 by 1024. So this is 0.3516 degree. So actually this is greater than 0.25 degree. So we cannot, n is not equal to 10. Now let's suppose take n is equal to 11 bits. Then resolution will be 360 degree by 2 to the power of 11. So that is equal to 360 degree by 2048. So this will be around 0.1758 degree. So that is less than 0.25 degree. Is imply that n is equal to 11. So the minimum number of bits that need to be there in the encoder specification for achieving an accurate measurement of this angle is n is equal to 11 bits. So this is minimum. So now we will solve the last question, not last question. There are three more questions left. So robotic application uses an absolute encoder with the following specification: 256 division per revolution. Output given as a simple binary number. The sector in the encoder follows simple sequential binary format. The signal status of the output lines from the encoder at a particular position of the rotor shaft is observed as this. So this is given as 00101100, and 256 division is there. per revolution. There will be 9 bits. So this 2 to the power of 0, this multiplied 2 to the power 1, we will change into the decimal value. Sorry, 0, 1, here will be 2, 3, this will be 5. So this will be is equal to 32 plus 8 plus 4. So that is 44. So one division, angle covered by one division equal to 360 degree by 250. So that is equal to 1.406 degree. So absolute angle of the rotor shaft is equal to, this is 44, so the value multiplied by angle covered by one division, so 1.406 degree. The answer will be 61.864 degree. So the option C is the correct option for this question. So we have solved almost the questions from the week 8th also. Now we'll solve some of the questions from the last part of this lecture series. So consider the operation of a base filter algorithm as described in the class. The world consists of a state of a door. It is either open or shut. So door is either open or shut. The robot has a single sensor that can sense the state of the door as open or shut. So the robot have a one sensor deployed on that. It can sense whether the door is open or closed. The robot has also an actuator that can push open the door. Like it can also push the door and if appropriate. The robot can also choose do nothing. Like robot can also choose that I don't have to do anything. It does not cause any change in the state. Given the information below, like in this question, compute the belief state after the following sequence of actions and observations. So, first, in this question, we have to find belief of x1 is equal to open or belief of x1 is equal to shut. So, for that, we have to find belief of x1 bar is equal to open. Okay, and belief of x1 bar is equal to shut. So, belief bar of x1 is equal to open. That can be given as probability of x1 is equal to open such that u1 is equal to nothing and x0 is equal to open into belief of x0 is equal to open. Like when initially the door is open and the x1 will be open even if the robot do nothing and x0 is open. Plus probability of x1 is equal to open given that u1 is equal to do nothing and x0 is equal to shut and belief of x0 is equal to shut. So here probability of x1 is equal to open and un do nothing and x0 is already open. So this will be 1 into belief of x naught is equal to open is given as 0.5 plus probability of x1 is equal to open un is equal to nothing, like, and x naught is already set, and if you do nothing then door will not be open, so this is 0 into belief of x naught is set is 0.5, so this will be 0.5. Now belief bar of x1 is equal to set, that is equal to probability of x1 is equal to set such that un is equal to nothing, means do nothing, and x naught is equal to open into belief of x naught is equal to open. Either x naught will be open or it will be set. The probability of x1 is equal to set such that u1 is equal to nothing, x naught is equal to set, and belief of x naught is equal to set. So this will be the first case, it will be zero probability because if initially it is open and if you do nothing, then it will be open only. So 0 into 0.5 plus if initially it is set, if you do nothing, then it will be set only. So this will be 1 into 0.5. So this value is 0.5. Now we will do the measurement update. So belief of x1 is equal to open is equal to eta. Probability of z1 is equal to shut such that x1 is equal to open into belief bar of x1 is equal to open. So this eta is equal to probability of z1 is equal to shut such that x1 is equal to open is given as 0.2 in this question, and belief bar of x1 open is 0.5. So this is equal to 0.1 into eta. Now belief of x1 is equal to shut is equal to eta. Probability of z1 is equal to shut such that x1 is equal to shut is given into belief bar of x1 is equal to shut. So this value is eta. Probability of z1 shut such that x1 shut is given is 0.9. And this is 0.5. Belief bar of x1 is equal to shut. Here we have found. So this will be equal to eta into 0.45. And this will be 0 eta into 0.1. Eta is equal to inverse of 0.1 plus 0.45. So this is 1 by 0.55. So belief of x1 is equal to open is equal to 0.1 into eta. So that is 0.1 by 0.55. When you calculate, you will get 0.1818. Belief of x1 is equal to shut is given as 0.45 into eta. So that is equal to 0.45 divided by 0.55. So this is equal to 0.8181. So in this question, which one is correct? Belief of x1 is equal to open is 0.1818 and belief of x1 is equal to shut is 0.8181. So the second last option is the correct answer for this question. So now we'll solve the last question for today's lecture. So first we will see Kalman filter algorithm. So the estimation xt is at x of t minus 1 plus bt ut minus epsilon t. Measurement zt is equal to ct xt plus eta. So you see the equation for Kalman filter algorithm. Mu t minus 1, sigma t minus 1, ut and zt. Ut is the action, zt is the measurement. So mu bar t is given as at mu of t minus 1 plus bt ut. Covariance matrix sigma bar t is equal to at sigma of t minus 1 at transpose plus rt. Kalman gain kt is given as sigma bar t ct transpose sigma bar t plus qt inverse. Finally, mu t is given as mu bar t plus kt zt minus ct into mu bar t, and sigma t is equal to I minus kt ct into sigma bar t. And Kalman filter return the estimation nu t and sigma t. So in this question, xt is given xt minus 1 plus ut. So here a is equal to 1, b is also equal to 1, c is also equal to 1. So we will solve, and also in this question mu t that is given as uh, initial belief that is given as Gaussian with zero mean and unit variance. So mu t minus 1 is equal to 0 and sigma t minus 1 is equal to 1, and the epsilon and eta are the zero mean Gaussian noise random variable with 0.1 variance, and u1 is given as 0.1 and z1 is given as 0.11. Okay, so Kalman filter algorithm, here mu t minus 1 is 0, sigma t minus 1 is 1, ut is 0.1 and zt is 0.11. So, and this is also, I will write it so that you may not get confused. Now mu bar t, mu bar t is equal to a and b and c is 1. So mu t minus 1 plus mu t. So that is equal to 0 plus 0.1, that is equal to 0.1. Sorry, this is ut. Sigma bar t is equal to sigma t minus 1 plus rt. So here that is equal to 1 plus, and here you can see the E epsilon and eta are the zero mean Gaussian random variable with zero point 0.1 variance. So RT and QT is 0.1. So this will be 0.1. So this will be 1.1. Kalman gain KT is given as sigma bar T plus QT inverse. So this is 1.1 into sigma bar T is 1.1 plus 0.1 inverse. It will be 1.1 by 1.2 equals 0.917. Now mu T is given as mu T bar plus KT measurement ZT minus mu T bar. At the belief estimation. This is 0 point belief is given as 0.1 plus 0.917, that is Kalman gain. ZT is 0.11 minus 0.1. So this will be 0.1 plus 0.917 into 0.01. So this will be 0.10917. Sigma T is equal to I minus KT sigma bar T, that is equal to 1 minus 0.917, and sigma bar T is 1.1, that is equal to 0.083 into 1.1. This is equal to 0.0913. So this Kalman filter will return the value of belief and the covariance. This will return mu T is equal to 0.10917 and sigma T is equal to 0.0913. So we have solved the question from each week, like we have solved around one or two questions from the each week. So this was just the extra session for the tutorial season. So today we'll stop the lecture here only. You can watch this lecture on YouTube. The link will be uploaded in NPTEL portal. And if you have any doubt, then you can ask in the comment box. We will reply there. Thank you everyone for attending. Bye bye. And all the best for your upcoming exam for this course.